All right, here's the Heelstone way out here. It says it's a huge unshaped boulder, hard sarsen stone, stands in isolation, surrounded by small circular ditch. It weighs more than 36 tons. In '79, a hole for another similar-sized stone was discovered next to it, which is the twin of it. It's the second foot. You got 1 foot here, and then you got another foot over here, and one of them, I don't know what they did with it, but it's gone. Now, this is the foot to the body, is my contention. That's all I can think of. Now, at one point they talk about these being these sarsen stones, and you have to go 25 miles to get these. Well, wherever the guy died is where they are. And here is what sarsen stone is. This is just like this exact same thing. And they say it's extremely hard, and yes, they're right. You hear that? That is hard. This is hard, hard, hard stone. And that's because it is from the creature's body. That's what it is. Now, this is some pictures I took of. This is what grip skin looks like. It's very, very heavy, keratin, thick, dense, very little blood in the skin. So you can't get a good blood sample out of that. So I had to break off a chunk of skin and drill down into the fingertip. I'll show you in a second. This is the actual fingerprints. That's the fingerprints. That's what I was just banging. You hear how hard this stone is? This is what they call a sarsen stone. Yes, it was, I know the whole process. It's nucleophilic substitution, it's aluminum, silicate invasion, That's the result. Let's close the case there. Now, where did that come from? That came from the fingertip. Well, where's the fingertip, Roger? Well, just give me a second. Here's the fingertip, right there. You probably know somebody that has a fingertip. That's what they look like. They have fingernails. They have a little bumper pad at the back where it bumps against the next bone so they don't scrub and rub and destroy each other. And they have fingerprints right almost touching the fingernail. So that's where it came from. This is almost 36 inches long. And guess what, mes amis? Whoops. I'm sorry. Hold on a second. You know, maybe that was manifest destiny. I got something in today from somebody who's in desperate need of trying to heal her twin children. And I have been working with somebody overseas who has a fabulous plan, and I am going to be going into another video about that. But she has helped, and she just went to Harvard and all that stuff for biology and a deep, deep stuff about, you know, the microbiome and all this. And I worked with her for years, and she literally healed her son of autism, of the most drastic type of autism. And they were going to put him in a locked ward because he couldn't do anything. He couldn't talk. He was just stimming and jumping and hopping and, you know, all of the things that happen when you have the most severe side of autism. And with the correct diet, literally that's all it is. Your body has to interact with every bit of chemistry coming in, and this is what does it, enzymes. And here's the problem, they don't understand. They think enzymes just come out of your body for no reason. They don't. These are produced by bacteria. That's the only thing in your body that makes anything is bacteria. They live in your membranes. If they are not embedded in your membranes in the correct places, in the correct quantities, you are invadable. Kabish? You are invadable. You can be, and plus, with the kids that have autism, the membranes that are coat the nervous system, they're called myelin membranes. Those are the things that are that particular type of collagen, and there's a ton of different collagens. They say there's 28, I say there's probably a lot more. But every one of them has a chemical signature, and it does a specific job. Some of them wrap kidneys, where there's a lot of salt, some of them wrap acids in the stomach, some of them do this, that, and some of them wrap the nervous system so that it doesn't short out. And the guys go, what do you think is happening? Why do you do that? It's like wires shorting out. And these enzymes need to be there to do the job, to create the products and create the mucus and create all of the products that work in these membranes. And the enzymes are the product of bacteria. And the bacteria is a product of having a good, healthy microbiome living in these tissues. All right, so that's it. Manifest destiny goes back to sleep. Okay, this is the DNA test that proves the things I'm talking about. The thing I was banging there, that fingertip, that's DNA was tested, and it was dense, and it was high quality, and it was human. Excellent quality DNA was obtained from the 36-inch tip and that lung that I showed you. And here's what they were: Homo sapien, mitochondrial B and D loop. And that's what they tested for, and that's what was there, and that signifies that they were human mitochondrial DNA. And the lab says they will stand behind this as long as you understand I was the one that did the extraction. If I did it poorly and sent them bad stuff, it's my fault. What they tested was what they submitted. It was right there: Homo sapien, case closed. All right, now look at this. This is of extreme interest. You see that right there? It's called a Heelstone. There was a twin to this Heelstone. Apparently it was over here. If this is correct, and these are actually the solstices and all that business, and these angles and so forth have meaning, there was a twin to the Heelstone, and it's been removed. And the Heelstone is a foot. And it apparently, this is the body of the giant, and these are his feet. Now, I'll show you the foot. All right, this is my nose hole. I'll show you in a second. It's in the microscope. That is the vein side, and this is the artery side. See the red and the black? That's the difference. I'm going to show you the one at Stonehenge, and you'll see the black blood is right in the same spot as the one I have here. You know, all the feet you have to have blood supply running down to your feet and then coming back up. The vein comes back up, and they clamp off, and it turns hard. That's the magnetite iron, which is the O3 version. This is the O2 version, which is the red blood, and that's the artery. That's going down to feed, and they purge and open up, and the red blood leaks out because there's no clamps. These have clamps, and they also have the proclivity to, you know, you know, they just turn into iron, hard. Which is that's what they do when they get in these substances in water and so forth, and as soon as they hit oxygen, well, actually it's mostly the oxygen, and I can show you how quick they can go from the red state to the black state. Watch this.